Hi, today I want to show you how to create a chatbot that can provide individual responses for different logged-in users. We are building a mini fitness app where the chatbot greets a user personally and incorporates age, gender and fitness level into its tips. The project is divided into two parts. In the first part we will create registration and login endpoints with FastAPI. We will then authenticate ourselves with a JSON Web Token on a secure endpoint. Since such a setup can naturally be used for other projects too, I want to make a cut there and integrate the chatbot with langchain into the API in part 2 in such a way that each user has a personal user experience. Ideally, you have a little bit of experience with FastAPI and or langchain for this project. I already have a crash course on both topics on my channel, which you are welcome to watch in advance. Before we start with the code, there will be a little introduction to authentication with JSON Web Tokens, so we will learn what actually is a JSON Web Token and why authentication with tokens is the most popular method today. A JSON Web Token authenticates a user on a server and is sent with an HTTP request in the request header. A JSON Web Token consists of three parts: a header, a payload and a signature segment. The header typically defines the type of token and the signature algorithm used. The header can look, for example, like this. Here you've got the algorithm and you've got the type, which is of JWT, which is an abbreviation for JSON Web Token. The payload segment contains the so-called claims or statements. These statements are about an entity, typically it's a user, and have some kind of additional data. For example, the name or if the user is an admin or not. The last part, the signature, is what secures the token. It is generated by taking the encoded header, the encoded payload, and a secret key, and the algorithm defined in the header, and then this creates a hash from it. So why is authentication with JWTs now advantageous over session authentication, for example? Modern applications normally run as microservice in some kind of cloud environment, and you can scale your application, for example a REST API, horizontally, which means you can have multiple instances of the same application. This is hard to do, and normally you want some kind of REST API to be stateless, so you can use JWTs. These are self-contained. They contain all the necessary information and therefore do not need to be stored in a database on a server side. This greatly facilitates the scalability of applications. So I'm here at VS Code, and as you can see I've got an app folder. This is where all of our app logic lives, and then we've got the main.py. This is the entry point for our application. So we will build these files step by step, and then we have a final application where we can register new users and log in and get a token back. So first we're going to build the schemas.py. This is the file where all of our Pydantic models live, and the Pydantic models are responsible for telling the API how the request body should look like. So first we're gonna import some classes, and these are the base model class from Pydantic. We import optional from typing and also enum from the built-in enum module. Enums are very helpful if we want some kind of categorical variables. So let's create our first class. This is the user level class, which inherits from enum, and we create a property like this, and the value of the property is then this. So our property beginner has got the value beginner, and we do it for intermediate like this and for expert like this. So we've got three different kind of categories for our fitness application. The next class we will create is the user base class, and this inherits from Pydantic base model. This is the same structure like the enum. So we've got a property, and then we specify what kind of property this should have. So we've got an email, a username, age, and the fitness level, and we can pass in our default fitness level like this. So we pass in the beginner level as default level here. Okay, from this user base class we inherit again, and we add the password category for the user base class, and we do it like this because in the API we want the user to pass in a normal password as a normal string, but in the database we will have a hashed version of this password. So we will create two kind of different classes, the database version and the version for the API. The next we will create the user in database class, and this just adds an ID and the config mode, which makes it easier for SQL Alchemy to convert this into a database class. From this user in database class we inherit again and create a user in DB class, and this one has got the hash password. So again, this is the normal password for the API, and this is the class for the database with the hash password. Okay, now we are done with the API classes and database classes, and now we can create the classes related to tokens. Here we get a new class called token data, and we inherit again from the base model. We pass in one attribute, which is the username, because we want to store some information in the JWT. Then we will create the token itself. So we store the access token property here as string, and we also store the token type, which is in our case a bearer token, which is the most popular type of token. So first we will import some functions from SQL Alchemy, for example the create engine functions or the session maker, and then we will create a database URL. We will just use SQLite, so we will create a test.db file, which is in our current folder here. This will be created when we start the app. And with this information, we will now create the database engine. We pass in the database URL and also some connect args, which is only needed for SQLite. Then we've got our engine. Okay, then we will create a session class, and this is done via the session maker function. We pass in some arguments like the bind argument, where we have to pass in our engine here. And then we will also create a new base class. This is needed for creating database models. We just have to call the declarative base method here to actually create this base class. Now we can create our getDB function. This will always create an instance of a new session. So we'll always have got a new session when we make a connection to the database, so we won't have any race conditions. This method here we will use as dependency injection in our API later. We can now use the classes we created here and go to our models.py and actually create our database tables here. So we will first import some classes from SQL Alchemy to build our tables, for example the enum or the column class, the string and integer, to define what kind of types a column will have. And then we will create the base class here. This is the class we will inherit from to actually create a table. We also have to import the user level class here, because we will use it here with the SQL enum. And then we will create the class. This class called user inherits here from the base class and gets a dunder property called user. So this user class name here is just for us for development, but this under the hood will be defined in the SQLite database. So first we will create an ID. ID is always needed inside a single table, and we set it here as primary key in our table. It will be a normal column, so 1, 2, 3, 4 and so on. We then will create a username column, and this column will be a string, and it should be unique because we will pass this username information inside the JWT to actually define or find out who makes the request. So you can't have duplicated values inside this column. Then we'll create the email. It should also be unique because you only want to register with an email once. Okay, we will also store the password of the user in the database, but very important, we will not store the plain password. We will store a hashed version. So a not human readable version of the password. So if our database gets stolen, for example, then the user data is not in danger. The potential thief could not do anything with the hash passwords. Okay, then we will store some user-based information, for example, the age, which is just an integer. It is not a primary key or anything. And then again, we will use the level here, and this will make use of the enum class, and we use our user level enum here. Okay, fine, that's our final table, and we can now build the logic to actually register and log in. Okay, now we will create the logic to actually create a JSON web token. We go to the security.py file. Again, we have to import some modules, of course, like crypt context class or the JWT module here from Python Jose. Then we will create 3 constants, the secret key, the algorithm, and the access expiry minutes. This is for the token validity, so it's only 30 minutes long by default. And the secret key should normally be, of course, a secure value, but for our purpose here, it's not important. Just keep in mind that this is not the best value for a secret key, of course. Okay, then let's instantiate the crypt context class. We can now use the PVD context instance here to actually create a password hash. We pass in a single string, our password, and this gets passed to the hash method of the PVD context class. So this function here returns a hashed version of our plain password. Okay, now let's create our create access token function. This gets an argument here, which is data, so we can pass in some data from the database here to this function, and we extract, for example, a username and pass it in our JSON web token. It also got an optional parameter here, which is the expires time delta. Since data is a dictionary, which makes it a reference type, we want to create a copy first to not manipulate some kind of single instance in memory and get some weird behavior. So we copy the data here, call it to encode, and then we check if we've got some delta here, which is by default none, and then we will just create the expiry date. So if we don't have any arguments here, we pass in just a time delta of 15 minutes. Okay, now we update the toEncode dictionary and pass in the expiry date. Then we will run the encode function of the JWT module. This will create a JWT. We pass in the dictionary as data, so our payload here. Then we pass in the secret key, and we also pass in the algorithm. All these parts are needed to actually create a JWT. And then we will just return the encoded JWT from our function. So now we've got the logic to create an access token, but we of course also want the logic to retrieve information from the access token. So we can do this in the auth.py. We will first import some classes again. A very important class here is from FastAPI security, the OAuth2 password bearer class. This makes it very easy to work with JWTs in FastAPI. I will show you how to do so. So we will first create an instance, an OAuth2 scheme from this class. This token URL is responsible for actually returning a JWT, and this OAuth2 scheme allows us to use this token in some kind of dependency injection in FastAPI then. We're gonna use it in a few seconds, but first we will create some kind of helper functionality, which will also be a dependency injection. So we will define the getUser function here, and what we're gonna do is we pass in a username, and we want to actually retrieve the username from the user table. So we need this because we want to extract the username from the JWT, and then we pass it to this function to actually retrieve the correct user from the database. With this function, we can now create our getCurrentUser function. This will be also used as a dependency injection, and we need the token, which we will inject in this function here with the depends class, and we pass in the OAuth2 scheme here, which will retrieve the correct token from this URL, and we also pass in the session object from the getDB function, which we defined here in the DB module. Okay, so we've got the token and the DB, and first we will create some kind of exception which we want to raise if we are not authenticated correctly. Then let's now create the actual logic, and we will use a try-catch statement here. And we now use, instead of encode, we use the decode function from JWT, and we pass in the JSON Web Token, which we retrieve from this token URL. And we also pass in the secret, and we also pass in the algorithm. So only with the secret and with the algorithm, it's possible to decode the token again. So now we've got our payload here, and from this payload, we want to extract the subkey. This is a default key, and we can extract the username from it. If we don't have this username, we want to raise the credentials exception here. But if we've got a username, we want to create a new instance of the token data and pass in the username here. And then we've got here our token data instance. If that didn't work, we will listen to the JWT error exception and then raise our custom exception here to the API. Okay, now let's run the getUser function. Again, we define that here, and we pass in the current session. And we also pass in the username, which we stored in the token data class. So we access it in this property, and this returns the database object. So the workflow is we extract the username from the payload of the token and then use this username to actually make a query to our database and to retrieve the database object. And if we've got the user here, then we want to return the user itself. Otherwise, we again raise our credentials exception. First, we have to import some modules, of course, and we import the API router from FastAPI. And here we also import every other module where we created our logic to create authentication, our schemas, and also the security logic. So this gives us access to all functions and objects from these modules. So first, let's create our API router. And this allows us to use the decorator here. And we will create a post endpoint, which we will call register. And we define a response model. This is the user in DB base model here in the schemas class. This is our response model. And now we will create our function, which we call register. And what is passed here is defined in the user in model. So we want to pass in email, username, age and level, and password. These are the 5 attributes we want in our request to the API. And then we also use dependency injection to always get a new session for our database. So now let's create our logic. First we will run the getUser function. We pass in our session from the database and we pass in the username, which is the user in attribute here, to actually see if we've got a user already in the database. If that's the case, we want to raise an HTTP exception, username already registered. We pass in a status code 400. If we don't have this username in the database, we again want to do this for the email, and again also want to run an exception because username and email have to be unique here. If that's correct, we will take the password and pass it to the get password hash function. So we will convert the password in a hash password, and the hash password will be used to then store all the relevant user information. Here we exclude from the user information dictionary the normal password and pass in the hashed password. So we will create an instance of the DB user here, and now we will run the add method and add this DB user instance to the current session. Then we will commit the session, and then we will just refresh with the current object here, and everything is set up correctly in the database. Okay, at the end we just have to return the database object from the API. Okay, now let's create the login endpoint, or we just call it token endpoint. This /token has to match the token URL inside our auth.py file. In this endpoint here, we use form data as some kind of attribute, and this OAuth password request form will actually create some kind of request form, and we can extract the data entered here. We will have a username and password attribute of this class. We can use it like this. We run again our getUser function, pass in the current session, and we pass in the username by extracting the username attribute from this form data object. Okay, now we've got the user, or we don't have a user. If we've got a user object, we want to check if our hash password equals the password from the form data. So there is the verify method from the PVD context object, and this allows us to compare a hash password with a plain password, and this will return true or false. So if this is false or this is false, we want to raise an exception. So we raise an HTTP exception, here unauthorized, so incorrect username or password. If everything works fine and we've got the username and the hashes are equal, then we will create a new time delta. This time delta object will be passed into the create access token function. This is the optional argument. It normally, if we don't pass it here, it just gets 15 minutes. So now we pass in the data and we pass in the subkey. This is later used to extract the username. Again here we gonna add it. So we add this is dictionary, and here we extract it again in the payload. So we retrieve the username like this, and we add the username like this. Okay, fine. Now we have created our access token, and then we can just return the access token. We do it like this in a dictionary format with the access token itself and also the token type, which is of kind bearer. Okay, now let's create our third endpoint. We will call it conversation because in the second part of the video, we will create an actually chatbot interface for this endpoint. In the first part of the video, we will just return the current user. And this is done by using a dependency injection. And here we use the get current user function. We pass it here, and then we've got our current user object. So there's a lot of stuff going on. Here again, we will extract the token, and then we will run the get user function, run it here on the database, and then at the end return the user. So we can just use it like this in the API route and only call this method once via dependency injection. And we now have the current user in our endpoint, and we could of course do this for all of our other endpoints too. So very nice. So what we're going to do here is only return our fake conversation. This is a secure conversation, and the current user, which is the current user. And again, this is the class here. So we have to access the username attribute by this dot username, and this will return the current logged in username. Okay, now we can create our entry point, our main.py. Let's now go to the main.py, and here we can just import the FastAPI class. We also need UVcorn to actually run our server, and then we need the engine and also the router from the routes file. Now we will create a FastAPI instance, call it app. And then we will use the base class here from the models and run the create all method here and pass the engine. So this is responsible for actually creating our database and all of our tables. And then we will include the router via the include router method of the FastAPI instance. At the end, we just have to run ubicon.run, pass in the app argument, run it on localhost and pass in the port 5555. So if you run Python main.py now, this should work and we should see our app. As you can see, our test.db file gets created and we can now register and log in users. Okay, now let's try our API. First, we will try to connect to the current user endpoint and just execute here. As we can see, we are currently not authenticated. We get the correct 401 response code. First, we will register a new user here. Here the email does not matter. We will just call it, for example, test user, and then execute here. And then try to get a token here first with the username, test user. And the password was the default, so it's called string. And this allows us to get back the access token. So as you can see, the access token looks like this. And the token type is bearer. So before we're gonna get the current user, I will show you something. And on the website JWT.io, you can pass in a JSON web token and try to decode it. We don't have currently the correct secret. As you can see here, we've got the invalid secret. This is only stored on the server side, so we would have to pass it here. But as we can see, even without the valid secret, we get our correct sub. So this is the user we pass in here in the create access token function. So you shall never, really never ever store some sensitive data here. Username is fine, but never store any passwords or credit card information or anything in a JSON web token. Okay, now let's log in here. Here we have this key icon and we can just log in with test user and string. Let's authorize here. And now we get the JWT in the request header on every request we make. So if we try the conversation endpoint again, this is just a single GET request we're going to make here. Here we can see the token gets passed in the request header. It's of type bearer and this is the actual value of the token. And now we can see this is a secure test conversation and the current user is test user. Okay, perfect. As you can see, this works. The app does what we expect from it to do. And now in the second part of the video, we can now create our secure and personal chat endpoint. See you. Bye bye.